All right, it all comes down to this. The change in f, say f of t, is this funny thing, which is the area, this thing right here, it stands for the area under the graph of f prime over that interval. Okay, this is what we call an integral. All right, so the first half of Calc 1 is, or maybe 2/3 of Calc 1 is the derivative. The other half is the other third is the integral. Okay, you can see that the integral is connected to the derivative because we have derivative there. Okay. All right, so let me talk about this notation a little bit. Okay, so let's say that's the graph of f prime of t. Okay, so if we want to find the total change, we can compute this thing. Like I said, the area. Okay, right. So so first of all, what's this? Why this funny symbol here? Okay, so this thing is like, this is an elongated S. You can think of it as an S. And it's just a stretched out S. Why an S? S for sum. Adding a bunch of things up, right? We're going to add things up from A to B. So let's say, first of all, that we're going from A to B. Okay, now this thing adds up infinitely many rectangles. The rectangles, this is like your width, your change in t, it's like your width, and this is your height. So your width and your height. Okay, remember if we were to cut, remember from the previous section, total change, if we were to cut this thing up into say 4 equal pieces and make rectangles. Let me do it in purple again. I'll use left endpoints again. Okay, now these are our widths. Our widths are change in t, and our heights are f prime of t of maybe of the left endpoint in this case. Right, so that's kind of the idea. We're summing up rectangles whose widths are dt, and whose heights are f prime of t from A to B, Now remember when we did this before, right? Let's say that let's extend B out further. Right, let's say that we extend B out to here, that there's going to be rectangles with a negative area, right? It's not, it's not that the actual amount of space is negative, but it's that f prime of t, or the height, is negative. So you have a negative height times a positive width, that's a negative number. Right, so remember we did some of those. Let's see. So these would give you negative numbers. And remember that some of the answers can be negative if we have more space below than above. All right, and so and in the same way, this thing can sometimes be negative if we have more space below the x-axis or the t-axis than above.